Okay, this video is meant for my Concepts of Algebra 2 students. We have a quiz covering Chapter 7 on Monday, and this will go over the various sections. It's a rather long one. I have about 9 problems, so buckle up and let's go. Solve the equation. So this equation has a power involved, the fourth power. So I'm going to put a box around this, x plus 3 to the fourth. And if there was something outside of this box, or after this box, I'd have to get rid of it first, but there's nothing. So I'm actually going to rewrite this problem down below. X plus 3 to the fourth equals 81. And now, you have to get rid of this fourth power, and the way you do that is by taking a radical of both sides. And that radical must have an index that matches the 4. So this is going to be a fourth root of both sides. And now, the first thing you say to yourself is, okay, this index, is it even or odd? And 4 is even, which means you get 2 answers. So on this right side, when you take the fourth root of 81, you get plus or minus on that side. Okay, this left side here, the fourth root and the 4 cancel, x plus 3. But on the right side, you get 2 answers, and the fourth root of 81, you can use your calculator, or maybe you know that 81 is 3 to the fourth. So this is just the fourth root of 3 to the fourth. This is 3. And now, since x is not by itself yet, I would actually take this problem and break it into 2. So I'm going to do it right here. And those 2 problems, one has plus 3, one has minus 3. So x plus 3 equals positive 3, x plus 3 equals negative 3. And now we solve for x in both cases. Subtract 3 here, x equals 0. There's one answer. And let's subtract 3 here, x equals negative 6. This is the other answer. And no need to solve, or no need to check your solutions. This will be fine. And there are your 2 answers to this exponent problem. Okay, next problem here, we're going to evaluate some expressions involving rational exponents. And I'm going to do each one. One I'm going to do using exponents, the other one I'm going to do using radicals. Okay, so let's start with the exponents. So this way, for problem 77, we'll be using exponents. So I will not use any radicals. So 100 is a perfect square. 100 can be written as 10 squared. So this problem can be rewrote as 10 squared raised to the 5/2. And this is actually a power of a power problem. And for a power of a power, you multiply the exponents 2 times 5/2. Well, what happens if I put this 2 over 1, this actually becomes 10 over 2, just multiply straight across, which simplifies to 5. So in reality, these 2's cancel. And this exponent, that is your exponent right here, 5. So this problem simplifies to 10 to the 5th power. And 10 to the 5th power, I believe, is 1 with 5 zeros. 1 with 5 zeros. And there's 10 to the 5th power. Okay, so that's using exponents. Now, let's do this next problem using radicals. Okay, so to do this problem, I'll use blue. First of all, there's a negative exponent. So we're going to use radicals. And there is a negative exponent, so that's going to flip this 64 on the bottom. 1 over 64, and then the power becomes positive. So we flip this because of the negative exponent. And now I'm very focused on this 64 to the 2/3. So the bottom number, the denominator, is the index of the radical. The top number is the power. And now hopefully I can rewrite 64 as something to the 3rd power, and you can. 64 is 4 to the 3rd power. And again, you just got to use your calculator to check these things or know it. Okay? So what happens is the 3rd root and the 3rd power cancel, and this problem boils down to 1 over 4 squared. And 1 over 4 squared is 1 over 16. And again, I could have done this problem using exponents. I could have done the first one using radicals. It doesn't matter. Okay? Either way is fine. Okay, next we're going to take a look at solving radical and rational exponent equations. So here's our problem. The square root of 21x plus 1 equals x plus 5. Your first step is to isolate the radical, which is already done. So this radical is all alone. I will put it in a box just to show you that There's nothing else on this side of the equal sign. So let me rewrite this problem down below. So this is the square root of 21x plus 1 equals x plus 5. What we must do is raise both sides to the power that matches the index. Since there is no index, that's a 2, so we must actually square both sides. And to the right side, I put that x plus 5 in parentheses, and I will square it. So on the left side, these cancel, and it's very simple, 21x plus 1, outside of that radical. On the right side, x plus 5 squared is x plus 5 times x plus 5. And you must FOIL this. The x goes to the first x squared, and the outer 5x. This 5 makes the inner and last, again a 5x, and a 25 multiplication. Then I will simplify this x squared plus 10x plus 25. That is what equals 21x plus 1. And now since we have a lot of these x's, and we have an x squared and x, we want to bring everything to one side. So let's bring everything to the x squared side by subtracting it. And subtracting the 1. So on this side we do get 0. And on the right side we get x squared minus 11x plus 24. And now I'm going to use blue up here. We're going to look at this as a ax squared plus bx plus c problem. Remember, ax squared plus bx plus c. We don't care about a because there is none, so the only factor I care about is the factors of c. C is 24. So let's start. The factors of 24 are 1 and 24. Now, my signs. If c is positive, that means the signs are the same. So then I look at the middle sign. They are negative. So we're going negative, negative. That's negative 25. That's not negative 11. Go back to the drawing board. 2 and 12. Negative and negative. That is negative 14. That's not negative 11. Go back. 3 and 8. Negative and negative. That is negative 11. There you go. Here are your magic numbers. Negative 3 and negative 8. They will go in your parentheses. X minus 3. X minus 8. That equals 0. Since they multiply to get 0, each of them might be 0, so we'll check to see what x value would make each one equal to 0. Here we'll add 3. X is 3. Here we'll add 8. X is 8. And we get two potential answers, 3 and 8. But as it says in the directions, and as we'll say on the test, you must check for extraneous solutions. So we must, I'm going to bring this down, we must check each of these solutions. So to check, let's start with x equals 3. That means we plug 3 in wherever we see an x. So that would be the square root of 21 times 3 plus 1 equals 3 plus 5. 21 times 3 is 63. 63 plus 1 is 64. That's the square root of 64. 3 plus 5 is 8. The square root of 64 is 8. That checks out. X equals 3 is a solution. Okay. Now we will check x equals 8. Square root 21 times 8 plus 1 equals 8 plus 5. 21 times 8 is 168. Plus 1 is 169. 8 plus 5 is 13. And the square root of 169 is 13. 13 equals 13. We have two solutions. And it's okay. It doesn't happen often, but this problem, you get two solutions. As long as you check them, you're good to go. Okay, so this problem is pretty much, I would call it 3b, but we'll call it problem 4. Same kind of idea, except now instead of having a radical, we have a rational exponent, but they're exactly the same thing. So in this problem, we have 10x minus 9 to the 3/4. I'm going to put that in a box. If there is something on the same side of the equal sign with this that's not in the box, you have to get rid of it. And look, the plus 1. Get rid of it. 10x minus 9 to the 3/4 equals 27. And now the idea is, how do we get rid of this 3/4 power? Well, the way to get rid of an exponent is to raise both sides to the reciprocal of that exponent. So the reciprocal of 3/4 is 4/3. And what happens on the left side is they cancel. And you get just the 10x minus 9. Now on the right side, we have to simplify this. Now, I'm okay with using a calculator, but this is really the cube root of 27 to the 4th, or the third root of 27 to the 4th. And 27 can be written as 3 to the 3rd. So the third root and the third power cancel. This is really just 3 to the fourth power, which is 81. This simplifies to 81. And now we just solve for x. Add 9 to both sides and divide by 10 on both sides. And I think that my answer is 9, but I'm not sure until I check. I must plug it in to check, and I will. So the check, 10 times 9 minus 9 to the 3/4 plus 1 equals 28. And now I will try to do this all at once. 10 times 9 is 90. 90 minus 9 is 81. Again, you can use your calculator. The fourth root of 81 is 3. 3 to the third is 27. Use your calculator if you don't trust me. But 27 plus 1 is 28. This is your solution. So the check is meant to be quick. It's not meant to be strenuous, not meant to be hard. It's just quick. Whether you get the answer, you get the left side equals the right side, or you don't. Okay? All right, so that's solving. That's section 7.3. Good. All right, here's our next kind of problem, our favorite kind of problem, the composition of functions. We're trying to find g of f of 1. I am going to do this problem like the following. Find g of f of x when x equals 1. So I want to practice by finding this first and then plugging in 1. So what this means, g of f of x, it means that f is going into g. So first thing I do is I replace the inside function with what it is, and that is 3x plus 4. Okay, and now I'm going to use colors to help you guys out. So now g is 2x squared. I'm going to write that right here. And I'm going to write it down here as well, too. But I'm not going to put the x. I'm going to leave a blank space. But I still put the squared. And in place of that x goes 3x plus 4. So hopefully maybe using the colors helps you see that you're just replacing one function into the other. It's not multiplication. It is substitution. Okay? And now we must simplify this. Add, subtract, multiply, divide if you can. Well, this 3x plus 4 squared is 3x plus 4 times 3x plus 4. It written twice. And I'm going to go ahead and FOIL that out first. The 3x goes to the 3x and the 4 to make 9x squared plus 12x. This 4 goes to the 3x and the 4 to make 12x plus 16. And I will simplify that. This is 9x squared plus 24x plus 16. So that's the binomial squared. But there's still this 2. You have to multiply everything by the 2 to make 18x squared plus 48x plus 32. And this is what that g of f of x comes out to be. 18x squared, moving up, plus 48x plus 32. But now, evaluate it when x is 1. So g of f of 1 is just taking the value of 1 and plugging in for our x. 18 times 1 squared plus 48 times 1 plus 32. And the 1's just kind of like go away. They don't really matter because it's anything times 1 is itself. So it's 18 plus 48 plus 32. That is 98. And there is g of f of 1. Okay? All right, hopefully the colors made a little bit of a difference for this problem. Okay, so our next problem is that word problem involving composition of functions. So you're buying DVDs on an online movie store. You get $15 off the purchase of any 4 DVDs, and you get 10% off your purchase if you open a charge card. And first of all, I want to build the functions. So x is your original cost. So whatever the original cost of the original price, whatever. Then we're going to let f of x represent the $15 off. And g of x will represent the 10% off. The 10% off. So our function f of x equals, well, you take the original cost, and to take the $15 off, you subtract 15. the function g of x. Now, if you're getting 10% off, that means you still pay 90%. 90% is still on. So you are paying 90% of the original cost. That's 0.90 times x. There are your two functions. And now I want to represent both compositions. So first, f of g of x. G is going into f, so f of, and g of x is 0.90x. I'm going to write f above x minus 15. I will not put the x in its place. I will put the minus 15 in place of x. I will put 0.90x. Add, subtract, multiply, divide. Really, you can't combine those, so it just is 0.90x minus 15. And this represents the 10% off first. So this right here is the 10% off first. Now, let's do the reverse. G of f of x. So that means f is going into g. So we will replace f with what it is. I will write the g function above. I will write it down below, but I will not put the x. Instead, I'll put a parenthesis space, and in that space goes the other function, x minus 15. And this one, we can actually multiply. We can distribute. And we get 0.90x minus 13.5. And this is if you do the $15 off first. Inside function first. And now, this is the 13, sorry. And now the follow-up question will be, okay, which way will the store make you do it? And if you look, in the top one, you get $15 off. This is $15. In the bottom one, you only get $13.50 off. So in the top, you're actually paying $1.50 more. So the store is going to make you do this, which is the I'm sorry. I am backwards. In the top, you're getting $15 off. In the bottom, you're getting $13.50 off. So the store wants you to pay more. So they want you to pay the one that you get less off. This is the one you get less off of. So the store will want you to do the $15 first. Store will take $15 off first. And again, it's just because they want you to pay more, and you pay $1.50 more. Okay. So there we go. All right, last section. This was section 4. Last section is section 6. Okay, last problem coming. We are going to graph this function. All right, and I'm actually going to change it. Sorry. So we're going to rewrite it as, so cross this one out. We're going to write it as y equals, we're going to go negative 2 square root of x minus 5 minus 3. That's the function we're going to graph. So make sure you change that on your paper. So first thing we're going to do is, I can't do it with my hand because I can't use my hand, but cover up the minus 5 and the minus 3. Your function is this. Okay? This is what we're going to graph first. This graph is going to be starting at 0, 0, and then we will shift it using the minus 5 and minus 3 later. Okay? So let me draw my graph down here. I'll try my best. So I'll go 5 in every direction. Okay? And to graph this guy, I know there are 2 points, 0, 0, and 1a. But I know that 1a is 1, negative 2 on this graph. So 0, 0, and 1, negative 2. And this is going to be my square root graph, but I'm going to dot it because that's not my final answer, okay? I'm actually going to move those points. And now comes the movement. And again, I'll use blue here. So this first minus 5, this is our h value. And h value move left to right in the opposite direction. So that minus 5 seems left. So you're actually going to go to the right 5. And then this minus 3 is the k value. It goes up and down. And you're going to do what it says. Minus 3, you're going to go down 3. So to both of those points, we're going to move to the right 5 and down 3. So this point right here, 0, 0, goes 1, 2, 3, 4, 5, and then down 3. Right about there. And that's going to be the point 5, negative 3. And we'll do the same thing to the other point. We're going to go to the right 5. 1, 2, 3, 4. Oh, I got to make one more tick mark. 5. And then down 3. 1, 2, 3. And that's going to be the point 1, 2. That's 6. 6, negative 5. Yeah, sounds about right. 6, negative 5. And now I'll make this solid. There. And this is the actual graph. That's what I'm looking for, this graph. Okay? And now the question is, what is the domain and range? Well, it's not that bad. The domain is x. The range is the y. Go left to right. Find the first point on your graph. That's this right here. That's these numbers. X, comma, y. The 5 goes with the x. The negative 3 goes with the y. You are opening to the right. So in x's terms, that's greater than or equal to 5. You are opening down in y's terms, that's less than or equal to negative 3. And here's your domain and range. Okay. So graph the graph without the shifts, and then graph the graph with the shifts after. Okay. Hopefully these problems helped you out. Bring them to class on Monday. Use them during your quiz, and we'll get a good grade. Thanks for watching. We'll see you on Monday.